Hi, I'm Oral, and today I will be talking about shapes of molecules. We can use VSEPR theory, which stands for valence shell electron pair repulsion, to determine the shapes of molecules. According to this theory, lone pair and lone pair repulsion is greater than bonding pair and lone pair, which is greater than bonding pair and bonding pair repulsion. However, in this video, I will be discussing only 7 of the shapes of molecules. For example, if we were to draw BeCl2 or CO2, it would look like this, with CO2 having double bonds on each side. However, this does not change the fact that both of the molecules have 2 bonding pair. So the name of the shape would be linear, and it would have a bonding angle of 180 degrees. For 3 bonding pair, the shape of the molecule BF3 would look like a flat triangle, and so this shape would be called trigonal planar, and it would have a bond angle of 120 degrees. Moving on to the non-planar and 3D shapes of molecules, we have 4 bonding pair. One of the example of the molecule would be CH4. The reason why we have to put a shaded and striped triangle to represent the bonds is because the shaded triangle shows that the bond is going towards the front, while the striped triangle is going towards the back of the molecule. This forms a 3D shape. The name of this shape would be tetrahedral, and with the bond angle of 109.5 degrees. There are variations of 4 bonding pair. For example, you would see that the H2O molecule has 2 bonding pair and 2 lone pairs. And the drawing would look like that with each of the 2 dots representing 1 lone pair. This shape would be called nonlinear or bent with a bond angle of 104.5 degrees. Other variations of 4 bonding pair can have 3 bonding pairs and 1 lone pair. The examples of these molecules would be PH3, NH3, and PCl3. Their lone pair would be on top and repel the bonding pairs at the bottom, since lone pairs has the greatest repulsion compared to the repulsion between bonding pairs. And so the shape of this molecule would be called pyramidal with a bond angle of 107 degrees. The next is going to be the shape with 5 bonding pairs. An example would be PCl5 or phosphorus pentachloride, and it would be called trigonal bipyramidal with bond angles 90 and 120 degrees. The reason why there are 2 angles is because the shape is formed by 2 pyramids attached together by its base. From the tip of the pyramid to the base, it would have an angle of 90 degrees. And from the side chloride to the other side of chloride, it would have an angle of 120 degrees. For 6 bonding pair, an example would be SF6 or sulfur hexafluoride. And the shape would be similar to the trigonal bipyramidal as before, but with a square base. The name of this shape would be octahedral with a bond angle of 90 degrees. And that's all the shapes that we have learned today. Thank you for listening.